I would prefer chapter 2.6.
Solving two-step equations and solving inequalities?
Yeah.
Okay. How are you doing in math?
I can actually pull on my grades and tell you everything I've gotten.
Has it gotten better?
I don't know. I haven't checked in a while.
Okay, well, I don't need to know. Just a general.
I'm pretty sure I'm getting an A.
Well, that's pretty good. That's what I like to hear. All right.
So,
Go
should we
through
do the...
Number 2, what would the first step be?
The first step would be subtract 4.
Okay, number 3, what would the first step be?
Divide 4.
Number 4?
Multiply 4.
Number 5.
Subtract. Wait, no, add 4.
Right. Okay. I like those. I like that problem. Go ahead. Read the next line.
2b equals 10.
Remember, my first step's going to be to subtract 7 from both sides.
Yeah.
So what's 3 minus...
Whoa. Whoops. So, negative 4.
Okay. And then v is equal to...
v is equal to negative 8.
Remember, we're going to divide by 2.
Oh, my brain is not working today. Negative 2.
All right. It's all right. Some days we have our A game, and some days we don't. I played golf today. I did not have my A game. I still had fun. It was fun. Okay.
So, the next line is 4b equals negative 12.
Is B equal?
Then b equals negative 3.
Okay. You want to go through these one by one?
Sure.
Okay.
And
See
so,
how fast you can do it.
okay, so 17, the next row is 19 equals 5k.
Okay.
And then you have to do, okay, 1 second, I'm thinking.
Okay. How do I get K all by itself?
You divide it by 5.
Okay. Next line.
The next, wait, 1 second. Oh, okay. Never mind. The next line is negative 6t equals 24.
And the next line.
T equals negative 3.
24 divided by 6.
is negative, 4. Thinking of 8.
Okay.
Then so you subtract 16.2
Okay.
and you get 14.6.
Negative 14.6.
Negative.
Oh, hold on a second. Oh, God, I just had a back spasm. I've been having a little back problems lately. Oh, played golf. I haven't done much physical in the last 2 weeks. I played golf today. Okay.
And then, okay, one second, let me get a piece of scratch paper.
Okay, you don't need a precise answer here. Just give it to me as an improper fraction.
Negative 14.6 over 8.
Okay. Now, is that an acceptable answer for your teacher, or does she want that as a decimal?
I'm pretty sure she doesn't like decimals and fractions mixed together. So, yeah,
Okay.
she doesn't like it when they're mixed together.
So we need to do this long division.
Yeah.
I'll put the negative sign in there, but I'm going to ignore it other than I know the answer is going to be negative.
Yeah.
Okay, so what is this?
So I'm solving it right now.
Just give me each line and I'll solve it.
Okay, so first you subtract 8 from 14. And then, wait, what do you mean the first line?
Well, each line. So now what do I do after I have a 6?
After you have a 6?
Yeah, I'm going to bring down that 6. And I know the decimal point goes right there.
So then you see how many times 8 goes into 66.
How many times is that?
And it goes into 66 8 times.
Okay.
And then minus.
You with me?
Yeah.
Okay.
And then you have to, then there's a 2 at the top, and that's
How many times
16.
is 8? How many times does 8 go into 20?
2 times. So a 2 at the top and 16. And that equals 4. And then 5.
All right. So that's the answer your teacher probably wants?
Yeah.
All right. What calculator do you have, David?
I'm not using a calc.
No, I know. I know, but you don't have this new Texas Instruments Inspire, do you? The CX?
My sister has it, but I think my sister has it at least.
She
But
probably does. It's the new calculator they're wanting everybody to get. You'll be asked to get it next year or whenever.
I have a regular calculator.
All right.
Well, regular graphing calculator.
This new TI Inspire can do so many things. It makes me wonder who has to do anything manually anymore. But
Yeah.
it's really quite amazing. It'll factor for you. It'll do most anything that I can think you'd want to be able to do. I'm just not positive it's a good thing. Okay, what's the next line?
Then you have to subtract 2.3.
Okay.
And so you're pretty much adding the negative to another negative.
Okay.
And
So the
you
next.
get,
Uh-huh.
I'm doing the math really quick. yeah, 21.1.
Okay.
And then you divide 21.1 by 5.
Now notice we're dividing a negative 21.1 by a
Yeah.
negative 5.
So it would come out as positive.
Right. So we know the answer is going to be positive. Okay, let's go through this. What's this number?
That'd be 4.
What's this number?
What was that?
What's this number?
That number is 2.
Okay, now you know how you put the decimal point, right?
Yeah, you just line
Pretty
it
much
up.
put it above it. But more importantly, my ballpark is I know the answer is going to be 4 and change, 4 point something.
Yeah.
So I know it goes right above there. Okay, so now we have times 10, and that produces a what? Another 2. That's it. In other words, there won't be any remainder this time. Okay.
So that makes G equals 5.22.
I think it was 4.22.
Oh, yeah, that's what I meant.
Okay.
And we are on 12, right?
Yeah.
No.
How come they're getting easier?
I don't know. I have a feeling. Oh, wait. Never mind. Okay, so then you add 5 and get 2t equals negative 5.
Okay.
And then you divide 5 by negative 5 by 2. And you get 2 and a half, negative.
Negative 2.5.
Yeah.
Okay. Let's see. Let me ask. How far can we go down? We can do all of chapter, whatever chapter this is. What is this chapter? We can do anything on here? Have you covered the whole chapter? Because it feels to me that these are too easy for you.
Yeah.
Let's go to 20. Let's spend our time doing stuff that's a little tougher.
Okay. And I was actually wondering if we could do maybe multi-step equations.
You can do whatever you want. You just give me the problem and we'll do it.
Yeah, the only problem is there's none on here.
Well,
in the book.
What did you want to do? What was it called?
Multi-step equations.
Multi-step equations, yeah. Well, almost all equations are multi-step if you think about it.
Well, yeah, but
these
more
are multi-step. In other words, I'm going to add a third, and then I'm going to multiply both sides by 5/3. So that's 2 steps. So I'm not quite sure what they mean by multi-step. 3 steps. I could make up some and give you that are harder. Yeah.
Yeah, 3 or more is what they usually do.
Okay, I got it. Well, one could even say this is 3 steps. Depends. What's the next line here?
You have to multiply by 3 and then divide by 5?
Not yet. In other words, we only want to do that after we've isolated that.
Oh, okay. Add 1/3.
Okay. So what's the next line?
3/5 G equals negative 11/3.
Okay, if I got negative 10/3 plus 1/3,
Oh, negative 9/3.
which is negative 3. Okay,
Oh, yeah, okay.
okay. Makes the problem a little easier. Now, you could say that that's step 1.
And then you
Now,
multiply by 3.
what's step 2?
You multiply by 3 on both sides.
Not by 3. You always multiply by the denominator.
By 5.
Okay, so let's multiply both sides by 5. What do we get?
You get G.
No.
Wait, no. 3G equals negative 15.
And what's the third step?
Divide by 3. And so G equals negative 5.
Okay. That wasn't necessarily 3 steps because we can actually solve it at this point. If you want to get a little fancy, we'll multiply both sides by 5/3, the reciprocal of this. That immediately now gets you G equals, that cancels with that, and I get minus 5. Notice that by multiplying it by 5/3, I completely get rid of that fractional coefficient.
Couldn't you also divide by... Wait, no, never mind. That's the same thing.
It is the same thing. Dividing by 3/5, yes. That's exactly what you're doing when you multiply by 5/3. Is you're really dividing both sides by 3/5. So it's okay to take this step as a shortcut as long as you always do it correctly. In other words, only take shortcuts if you don't make mistakes. If you find yourself taking this shortcut and making a mistake, in other words, a lot of people will make the mistake of multiplying both sides by 3/5, like that. Well, if you do that very often, then don't do that. Let's do it in 2 steps. First step being multiply both sides by 5. The typical first step would be to multiply both sides by the denominator. And then the next step would be to divide both sides by 3. So depends on how you want to do these. Sometimes you can take a shortcut, sometimes you can't. It kind of comes down to how accurate you are in making your shortcuts. Let's see, do we have any difficult ones there? Yeah, let's have you do this.
So,
Is that a divide sign? Or is that a plus?
that's a plus.
Ah, that's not a difficult one then. Let's go on. Let's find another one. That's easy. All of these are easy, right? You don't
I
see
think there might be some multi-steps equations. Here, I'll pull it up and look for it.
21 is tougher. 21 is tougher. I mean, if you find others that you want to do, fine, but 21 is definitely tougher than what we've been doing. If nothing else, it requires you to find a denominator, common denominator. Okay, what's your first step here?
Add 5, 6, and, add 5, 6, and you can, turn 1 over a half into a, common denominator of, 3/6, negative 3/6, and then you get, 2/6, which is also equal to 1/3.
Okay. Now what?
then you multiply by 4, and you get A equals 4/3.
Okay. Now, I'm going to show you one other technique for doing this problem. And I will let you determine whether you like it or not. It works rather nicely whenever you have a denominator in virtually every term. Notice we have a 4 here, a 6 here, and a 2 there. If I wanted to, I could eliminate all 3 denominators with one step. What would I have to do? What would I have to do?
Multiply by 12.
Exactly. Multiply every term by 12. And I like this step. I like doing this because I like getting rid of my denominators as quickly as possible. So what's the next line?
One sec. Okay. A minus.
Hold on. We got 12 times A over 4. What does that equal to?
Oh, 3A.
Okay. This is 12 times 5 over 6.
Oh, okay. 1 second. I got it. 10 over 6, I believe. Right?
Close. In other words, you cross that out.
Oh, 10 over 1. So 10.
Okay.
And then 6, negative 6.
Okay. Now, you see how in one step we turned a very complicated looking equation into a very simple equation. And we did it a little different than the way you did it the first time. First time you had to move the 5/6 over, and then you had to find a common denominator between 2 and 6, which was 6. Easy enough. So, but remember this technique. It can come in handy sometimes in a more complicated problem, where if you have nothing but denominators in every term, try to find a common denominator that you can multiply by to get rid of all the denominators in one step. All right, let's try 23.
And also, I'm pretty sure I remember where the multi-step equations are.
Okay. Let's do 23 and then we'll go there.
Okay. So, first you add 2 to both sides.
Okay, so the next line.
4 times b over 3 equals negative 1/2.
B over 3 or negative B over 3?
Negative b over 3.
You cannot drop that negative sign, remember. When you move the 2 to the right side, you haven't affected that negative sign at all, so it's still there. Equals what?
Negative 1/2.
Okay.
And then you multiply by 3.
Okay.
In this case, you get 1.5 equals b.
Okay. That's the correct answer. But notice, I really multiplied by negative 3.
Yeah.
In other words, I'm going to do that in one step. I'm going to multiply both sides by negative 3. And that gives you a positive 3/2 and a positive b. I don't really need to do this in 2 steps. I don't need to multiply by negative 1 and then multiply by 3 as a second step. I can do it all as one step. Okay? All right, where should we go to find those multi-step equations?
Chapter 10.
I only go up to chapter 2 here. Do I have to back up more?
Yeah, one more.
Okay. Which part? Where?
10.1. And then my math teacher said that there was a question involving a circle on there, and just to ignore that because we haven't learned it yet.
Okay, I was looking for the exercises. Took them a while to load. Okay. Oh, I see why they call this multi-step. So we have minus 3x plus 7x equals 17 plus 11. What's the next line?
Well, you have to, I forget what it's called, but, combine like terms.
Okay, correct.
Then you get 4x equals 28.
Okay, which makes x equal to
7.
Okay. Next one, 3x plus 12x minus 20 equals 25. Next line.
You have to add like variables, so 15x minus 20 equals 25.
And the next line.
You add 20 and then you get 45.
And the next line.
X equals 3.
All right. You know what our problem is? We don't have difficult enough problems for you.
Yeah.
Of course, that's why you're getting an A. That's a good thing. But, all right. Well, this is good drill. This is good practice. Let's go through number 8. Next line.
So you have to add all like variables.
Okay.
So you get 2n plus 15 equals negative 3.
Okay, make sure your sign. You tend to be a little,
2n.
yeah, you tend to be a little bit lazy on your sign. In other words, the only mistakes you ever make are with the sign, plus or minus sign. But those are big mistakes. Those will cost you the answer.
Oh, 1 second. Let me mute that.
Okay.
Okay.
What's the next line?
So you subtract 15 and get negative minus 2n equals negative 18.
Okay, and the last line?
And then you get n equals 9.
Good. All right. This next problem looks a little different. What did we do? Yeah, number 9. 3 times 2m plus 9 minus 1 equals 2. Okay, what's the first step here?
So the first thing you have to do is distribute.
Okay.
So
Actually, there's a couple of first steps here. I could choose to move this 1 over to the other side as a first step if I wanted. Or I could distribute this as a first step. And I don't know that one is more proper than the other, but as long as you know this particular problem, you can go either first step. So if we distribute that, we get 6m
plus 27 minus 1.
Okay.
And then now you add 1 and get, oh wait, no, now you add like terms.
Okay.
And yeah. So then you subtract 26 from both sides and get 6m equals negative 24.
Good.
And then when you divide that, you get m equals 4. Negative 4.
Negative 4. Okay. That one's too easy. This one, let's try this one. Okay.
So then you distribute and get 2/3 y minus 8 equals negative 6. And then you add 8 and get 2/3 y equals 2. And then divide by 2/3 and you get 1/3.
Okay, now see, that's a mistake. And we don't want you making that mistake. So I'm going to suggest to you that you always do this in 2 steps. What would the first step be?
Multiply by 3.
Okay. What's the next line?
2y equals 6.
Now what?
Oh, okay, I see where I went wrong. So yeah.
So you'll never make that mistake if you do this in 2 steps. I'm not telling you to do it in 2 steps because any other reason. I do this in 2 steps myself because it's real easy to get this thing backwards. When you try to do it in 1 step, when you divide both sides by 2/3, it's real easy to come up with the answer you came up with, which was 1/3, which was incorrect. So just always do these in 2 steps. Multiply by 3, the typical first step, and then divide by 2. My number 13. Give me the equation for that.
Okay, so 25 more than 3, so 25 plus 3
More than three times something.
So it'd be, yeah. So it'd be times a number.
Let's go back and start. We left out our critical first step. Remember what I said the first step of any word problem was?
No.
Define your variable.
Oh, okay.
Okay, and always go to the last thing they ask. Find the number. X equals the number that we're looking for. Now it becomes much easier to write an equation. What's our equation?
So, 25 plus 3x minus 9 equals 43.
Very good. In other words, that makes all the difference in the world. Once you've defined your variable and you know what it means, now it's pretty easy to go back and write the equation of these words that they're giving you. All right. You know how to solve this. That's just 3x and combining all these terms, all those like terms.
And then
when you get to problems like this, it's not the answer that matters, it's did you set it up correctly? And yes, you did set it up correctly. Let's look at 14.
Uh,
14's a hard problem.
I've never learned anything about a cylinder.
Ah, okay. Well, that's because it's geometry.
Yeah, we skipped from chapter 4 to chapter 10.
Okay.
I mean,
Well,
chapter 2 to chapter
you haven't
10.
had geometry yet. You
No.
probably, you're in 8th grade or 7th grade?
8th grade math.
So you'll probably take geometry next year, I suspect. I don't think they're going to make you take Algebra 1. Am I correct or not? Will you take Algebra 1 next year or geometry?
Algebra 1 and I don't know, actually.
You want to take geometry. You're smart enough and your math skills are good enough that you should take geometry next year. Now,
Yeah.
if they insist that you take Algebra 1, and I don't know why they would, because what we're doing is algebra here, and you know how to do it.
Yeah.
So, but if they insist that you take it, I would try to take both. Get your algebra and geometry out of the way if you're capable of doing it.
Yeah, because I didn't get to take the test to see if I would go straight into algebra last year. I had a concussion,
Okay.
so I wasn't able to take the test.
Okay.
And that happened.
Mm-hmm.
So,
Okay.
yeah.
Where'd you get the concussion from? Sports?
I was walking, this is actually really, really lame. I was walking out of the door in my school, and the door came back, hit me in the head, and then I banged my head against the door frame.
Uh-huh.
So, in 2 places, I hit myself on accident.
Wow.
Yeah.
Okay. Well, I don't see any other interesting problems here. Shall we go back to, let's see, we were on 10.1. Let's take a look at 10.2. Have you covered this material, or is this you're trying to get ahead, or what is it?
We started on 10.1, but we haven't done this yet.
Okay. I'll bet you can do this without looking at any of this examples. Let's get you a head start on this chapter here. See if you can figure out how to solve this.
Okay. So, I actually don't know.
Okay, gather all like terms.
Oh, okay. So, negative 3x minus 6.
Okay. That's one way to do it, is to move the 2x to the other side. But it makes more sense to move that x to this side for a couple of reasons. First of all, it leaves all the numbers positive. Second of all, it puts x on the left side, which we're all more comfortable solving. Agree? Aren't you more comfortable solving when your variable's on the left side of the equation?
Yeah.
Okay, so if we add x to both sides, what do we have?
3x equals negative 6.
And x equals
2.
negative 2. See why it's negative?
Yeah, because you're...
Okay. That's the only mistake I see you ever make. I'm not sure why. Okay, let's look at this one. Just pay more attention to your sign. It's the only thing I really would say about that.
So, you do like terms and stuff.
Okay.
And so, it's minus 9 equals 3c.
Good.
And then c equals negative 3.
All right. Very good. See, these aren't that hard.
Yeah. And then, so, you just add those together and get 4y.
What's left on the, well, give me the next line.
4y, correct?
That's correct on that side. No, actually it isn't. In other words, what do I have to do to move? Think of when you're moving something to the other side of an equation. Think of it like that. If I want to move this 3y over to there, is all I have to do is do it and change the sign. What that leaves over here is 0. Right?
Yeah.
Now what's the answer?
0 equals y.
Exactly. It's the only answer that works. Notice what else I could not do. I cannot divide both sides by y. Notice if I divide both sides by y, I get minus 3 equals 7. The reason is because you can never divide by 0. And if 0 is the only solution, the moment we divided by y, we lost that solution. It disappeared forever. So you got to be careful about dividing both sides by variables that might be 0. Okay? It's just something to watch for that you want to be careful about.
And there's just something I was wondering. Is it possible to have a negative 0?
No. On the number line, there's 0. Everything that way is negative. Everything that way is positive. And if you're looking at integers, these are integers, including 0. 0 is an integer. However, positive integers are just those, and negative integers are just those. 0 does not have a sign on it. It is neither positive nor negative. It is an integer, but it's not positive or negative. Okay. How about this one?
So first you separate the like terms, and you get negative 4a equals 2.
Next line.
And then you divide a by negative 4, and get a equals negative 0.5.
Good. So you can see that these are really no different. The only difference is we're adding variables together. Whereas in the previous section, we were only adding numbers. We didn't have where we had to combine variables. But, okay, so these are all pretty much the same. I don't see anything difficult here. If you see one of these that looks difficult, holler and we'll do it. They're all the same exact principle. All right, let's go to the second part here. 17. Here's more of your multi-step equations. This would definitely be it.
So first you've got to distribute.
Okay.
So 2k minus 8 equals 4k plus 4.
Now it becomes a problem just like everything else. But let's go ahead and finish it.
So you get negative 2k equals 12.
It's good. I don't mind it when you do those two steps in the same one. I think that's good to do. I do that myself. It's not that hard to keep track when you're combining the k's and you're combining the numbers. So when you do those two steps in one step, it's very little chance of making a mistake. So now k is equal to?
The way I always did it was draw little lines from where I wrote the number that it came out to from the numbers. So like a little arrow, just so I don't forget.
Oh, so like this, kinda.
Not really. Kind of more like, if you press the shift key and then press the comma or the period button, kind of like that, but pointing down.
Okay, well, you know what? It really doesn't matter. Everybody tends to have a unique way of doing math. And they're all, as long as you take the same number of steps as somebody else, then your way is as good as somebody else's way. Okay, let's do this one.
So you got to distribute.
Okay.
So 3g minus 9 equals 12 minus 4g.
Okay, what next?
And then you combine them and get negative 21 equals 7g.
Okay. How'd you get negative 21?
You subtracted 12 from both sides.
Okay, you can do it that way so that I would have negative 21, but then this is going to be negative 7g.
Oh.
And I would also advise to always move these things in the direction that's going to give you the most positive numbers. Okay, you're still going to get the correct answer. G is equal to 3. But notice that if I move the g's to the left and the 9 to the right, I end up with 7g equals 21, no negative numbers. G equals 3. Nothing wrong with negative numbers. It's just that when they're there, there's more likely to have mistakes made. And that's really what math's all about, is trying to do a problem without making mistakes. So that's just something I usually keep in mind when I'm trying to determine which side to move stuff to. In other words, if I want to move my variables to the left side or the right side. Whichever one results in a positive number on the variable, that's usually the way I go. Okay? I don't care so much about the negative number on the number, but I'd rather have a positive number on my variable.
Okay.
Okay, let's try this one. Next line.
So you distribute, which is negative 5f plus 2.
Hold on.
Oh, you're
You
my bad.
multiply.
3 plus negative 35 equals?
Just minus 35. Let's not put that extra plus in there if we don't need it. Okay?
Equals 9f minus 3.
Okay. Next line.
And then you distribute.
Okay. Well, not distribute. You combine like terms.
Well, yeah.
Okay.
And you get 4f. Wait, is that right?
Well, depends on which way you move it. Don't know which way you're going to move it to. I don't know if you're moving this over to here or if you're moving this over to here.
So it's 14f.
Positive or negative?
Positive.
If it's positive, it's got to be on the right side of the equation. It's the only way it's going to be positive. So you wouldn't read the right side of the equation first. In other words, I don't have any problem with doing that. And then you add 3, so the next line would be minus 32 equals 14f. And that's fine. That's actually probably the way I would do that problem. I would move that over to there so that I left this coefficient positive. And then that would force me to move this number over to here. In other words, I can't eliminate all of the negatives just because I want to. I'm going to have a negative either with the variable or with the number, whichever way I do it. Notice that if I do it the way you did it, which apparently I think was to move that to the left, that's fine, but you get minus 14f. And if you move this over to there, you get plus 32. So you still get the same answer. F equals minus 32 divided by 14. So it's really just a preference. It's not anything big. It's not anything that probably anybody else would teach you even. It's a personal preference of mine as to how I want to do these. Some people really feel strongly about having the variable on the left side of the equation. Other people feel strongly about having the variable not have a negative sign in front of it. And you can't do both. In other words, if you want it on the left side of the equation, it has to be like this. If you want it to not have a negative sign in front of it, it has to be like this.
Okay.
All right. What else we got here? Well, these are the same problem, only with decimals. That doesn't give you any problem, does it?
Nope. If anything, I'm actually better with decimals than I am with fractions.
Are you? Okay. Let's look at some of these word problems. I don't think you can ever get too much practice with word problems.
Okay.
Now notice in this word problem, 28, we don't have to define a variable because they already have. They define it in the word problem itself. They didn't have to. They could have probably just said 2 more than the product of a number and 3 is equal to the product of the number and 4. What is the number? Then we would have had to say, okay, let's let n equal the number. But they've already added that in, so we know that n is the number. Now let's write the equation.
So, number 29, right?
28.
Oh, okay. So it'd be 3n plus 2. Wait, one moment.
It's all right.
Okay, never mind. So, it'd be 3n plus 2 equals n 4n.
Very good. Solve that.
And so you add the combine like terms, and I got 2 equals n.
That's right.
And there we go.
Okay. Now let's just check it. If n equals to 2, then what is 2 plus 2 times 3 would be 6, and that's supposed to equal to 2 times 4, and it does. So you don't always have to check your answer, but if you have time, it ensures that you're right. In other words, if we made a math error in this, and n was actually 3 and not 2, it would have been exposed when we go back and plug it in and see if this equation is true when n is equal to 2.
Yeah.
Okay. Got time for maybe one more here. How about 29?
So 29 is 5n minus 3
Very good.
equals 6n plus 8.
That negative sign, what do we do with that?
Oh, negative 6n plus 8.
Very good. You put that last, which is where it belongs, even though they put it in the beginning. They always put it in the beginning. So whenever you see less than at the beginning, you know that that number needs to be subtracted from this. Okay, and let's solve.
You get
Solve this.
11n equals 11, and then you get n equals 1.
And you'll notice that works. We get minus 2 on that side of the equation and plus 2 on that side of the equation. Hold on.
So,
oh, no. 5 minus 3 is plus 2.
yeah.
Plus 2. Okay. Helps when you're doing your check if you do the math correct. So, all right. Well, that's good. David, you're coming along good.
Okay, thanks.
Yeah, you're doing real well. Glad to hear you getting an A, and you're doing, you're understanding this stuff very clearly.
Yeah.
Okay. I'll talk to you next Wednesday.
Great.
All right. Bye-bye. Have a good week.
You too.